I'm Pete.
I'm Stephanie, and this is the Cool Part Show, our show all about cool, interesting, innovative 3D printed parts.
This drone looks, even moves like a bird of prey, so much so that its inventor built a business out of scaring birds.
The company is now scaling up using 3D printing for some key components of this drone.
The drone bird on this episode of the Cool Parts Show. The Cool Parts Show is brought to you by Carpenter Additive. When it comes to managing metal powder, there is no one-size-fits-all approach. Stick around after the episode to learn more. Welcome to the Cool Parts Show.
If you like the show, make sure to subscribe on YouTube to get notified about our new episodes. And as a reminder, you can also sign up for our All Access newsletter to get notified about new content before it appears publicly here. On this episode of the show, we're going to be learning all about this drone that flies like a peregrine falcon.
Yeah, manufacturing drones is an important application of 3D printing. Remote aircraft are made that way, and this drone leverages some of the advantages that 3D printing brings to other drones. Advantages like assembly consolidation, lightweighting. But then there are other 3D printing benefits that apply to this drone in particular, notably biomimicry.
But this is biomimicry in sort of a different way than we usually associate it with additive manufacturing. Like, we've seen these crazy topology optimized structures that look like they come from plants or from cell structures or for something else in nature. But this is sort of biomimicry on a macro scale. The entire drone looks like a peregrine falcon. It uses its wings, it flaps its wings to fly. And it doesn't look exactly like a raptor when it moves, but it looks close enough.
All of that is valuable because of the function this drone performs. It scares away real birds, scares them away from situations, settings where they could be a danger or a problem, like airports or industrial facilities or power plants or agriculture. The drone bird company engineered a solution to that problem. And the aim of biomimicry in this case is, for that purpose, being scary.
But this was sort of an accidental discovery. This company comes out of research to develop a bird-like drone. And the added benefit of scaring away problem birds was something that they sort of discovered along the way. So let me introduce you to Jan Willem van den Eykel. He is the CEO of the drone bird company, also goes by JW.
Okay, this company started about 8 years ago, and basically it was established by a student who was doing a master thesis on making robotic flying birds. Basically, how it works, birds see our robot, which is mimicking a peregrine falcon, actually as a real peregrine falcon. And 85% of the birds species in this world are very afraid of a peregrine falcon. Birds are very clever, very intelligent. They get used and habituate to all kinds of means, like lasers or gas cannons. But we don't see any habituation with the falcon. And that's because of this fear is so deeply tied in their DNA and their instinct. Even one day, chickens, when they hatch out of the eggs, they already show response to peregrine falcons. And the other thing is, when I take you as a human as an example, and I will drive my truck towards you with a high speed, you will step aside every day again, even if I do it daily. So that's the other factor. Something is coming towards you with great speed, and that combined with the mimicking of peregrine falcon gives this great effect.
So that master's thesis on robotic birds connected to a valuable industrial application. A company was formed, and that company then needed a way to produce more of these drones, manufacture them effectively.
And there's a lot that goes into one of these drones. So you have the tail, the wings, this body that they call the fuselage on the outside that all has to look like a bird. But then inside you have all of the motors and the electronics and everything else that you need to make this work.
So there's a lot of software next to the mechanical things going on and next to the materials to build actually this bird. All starts basically with making it fly stable and fly like an actual bird. And I think the most complex thing was getting the mechanics right and the wing profile, together with, of course, the use of materials and getting the weight right. We are talking about making 1 kilo fly like an actual bird with flapping wings.
So making 1 kilogram of equipment fly as if it's a bird is challenging enough, but there are some other considerations that have influenced manufacturing decisions around these drones. So for one thing, the drone is battery powered, so you want it to be really lightweight. The lighter the weight, the longer the battery life, the more you can fly the drone and the more effective it can be. Secondly, it needs to be very durable. You might notice that Gertie here doesn't have any sort of landing gear, so she needs to be able to withstand a potential crash landing. And so the need to achieve a lightweight and durable drone led the drone bird company not to additive manufacturing originally, but actually to composites, to a hand layup process for some of these parts.
Basically, manual labor with glass and epoxy. So you create a mold, and from this mold you basically make layers with glass and epoxy to get to the actual shape. But it's very time consuming, and it's also very tedious work doing this with manual labor.
Manual labor. They wanted to get away from that in producing components that are lightweight, durable, complex shaped, organic shaped. 3D printing was a natural fit, and the drone bird company saw that from the beginning. They were using 3D printing already to make prototypes, but scaling up into production with 3D printing was a different matter.
So they worked with this company called Parts on Demand to move into production through 3D printing. This is Neil Van Ice. He is the CEO of Parts on Demand.
I got involved with the Dronebird project. I think it was like 5 years ago because Jan Willem reached out before they were producing the Dronebird in like a conventional method. So I think it was like glass fiber molding, and they did some first prototypes with 3D printing with one of the FDM printers, and we're searching for a partner to like basically give them more freedom of design, a more industrial way of 3D printing, and a better quality of product.
That more industrial mode of 3D printing that Parts on Demand turned to was selective laser sintering on a machine from EOS. Selective laser sintering, powder-based process, polymer in a powder form is fused together to make the part. The material is important, we'll get to that in a minute, but selective laser sintering, SLS, allowed these parts to be made not just repeatably, but also many pieces at a time, all in a single 3D printing build.
So the workflow typically is that we don't produce a single part, but we produce in batches of parts. We basically have a cubic volume that we fill with many parts that need to be produced in the same batch, just as a giant Tetris puzzle. That entire batch is sliced into layers, and the layers are sent to the printer. And the printer manufactures that by laying down a layer of powder, heating it just below the melting point, and then selectively fusing the cross sections of the parts with the laser.
So compared to that manual composites layup process, SLS is a lot more automated, it's more repeatable, it allows you to make lots of bird bodies at once if you need to. But as Parts on Demand got into this work, they started to wonder if they were using the best possible material. They do a lot of printing with PA12 nylon, and that's sort of what they started out with. But they started to wonder if they could reduce the weight of these drones even further while still maintaining the durability and strength by switching to a different, more specialized material. So for that, they turned to ALM, Advanced Laser Materials, which develops powders for additive manufacturing. ALM is also a fully owned subsidiary of EOS, which also supplies that SLS equipment that Parts on Demand uses. Here is Sam Houston. He's the senior manager at ALM Global.
The material that's used in the bird drone in this case is a material called the PA640 GSL. And it's a material with a nylon 12 with both carbon fiber and hollow glass. So it provides extra strength, a very nice surface finish, all while being very lightweight. So the 640 GSL is interesting in the sense that it is a nylon 12, but the combination of carbon fiber and hollow glass beads give it some significant benefits over just maybe a standard nylon 12. It's also very easy to process like a nylon 12. It's got good thermal stability, continuous use at around 150 degrees C. It's so light that it will actually float on water. Also, the benefits of it lightweight, its part density is 0.2 grams per cubic centimeter. So that's even less than something like a standard nylon 12. It's a good material for applications that require strength and weight ratio. And in this particular case with the drone bird, those were the two most important requirements, is strength and weight. So the material that needs to be strong enough for all the hazards of flight, which might include, like, I don't know, something like the hidden power lines or an occasional tree limb while soaring through the air. And then for the weight side of things, you want it to be as light as possible, because that's going to allow the battery to last longer and allow the bird drone to have longer flight time and even faster if needed.
So the Drone Bird Company, its manufacturing partner, Parts on Demand, its material supplier, ALM. So they've got the process, they've got the material. Next up is optimizing the design. The purpose of this drone is simple, scaring birds, but the design considerations for getting to that are pretty numerous. There's a lot going on here. There are electronics that have to be mounted securely inside the body of this drone. It has to do that within components that ought to be easy to assemble, and the whole thing has to be lightweight. And in fact, lightweighting proved to be a major consideration. So the team set about making this drone as lightweight as possible.
With 3D printing, we can do a lot of function integration. So a lot of parts that needed to be assembled, like the mounts, we could now print into the actual fuselage of the drone bird. And these drones are all about saving weight. We were working towards the absolute minimum of all thicknesses to reduce every single gram of weight we could find. Put all the functionality of the mounts in there, so the guys at Jan Willems only needed to install like the little things like motors, batteries, cabling, and the rest would be a self-contained unit, basically.
In the internals of the body, we mount all kinds of electronics like flight control, but also the servos to control the tail. And all these mounts basically are already pre-printed in the body. So we just have to screw it down, the electronics which you want to fit. And this is all being taken care of by the printer for us.
So the drone birds have been through this whole evolution, from hand layup to SLS 3D printing, from PA12 nylon to this new glass-filled material, and from this very tedious assembly process to something that's much more streamlined by virtue of these 3D printed parts.
Production of the drone bird is underway. JW didn't necessarily expect that. His business was initially a service, but there's so much demand for that service, for the work that this drone can do, that mass producing these drones to sell to users has proved to be the next step. Parts on Demand is helping with initial rate production and also helping with the introduction of new design options. Like this. This is a variant on the drone bird. This is a fixed wing design instead of this version that flaps its wings.
At first, we start out as a service, especially the robotic flapping falcon, because it was at that time still very complex, a lot of maintenance, etc. Now, after the enhancements, it is ready to sell. We've sold now a few of them, but mainly we are now focusing, and that's because it's much cheaper for us to produce and much cheaper for the client. We also sell the fixed wing peregrine falcons because we have seen, although they are maybe less sexy because they are not propelled with flapping wing, but with a falling prop in the nose, but the effect on the birds is actually the same. We are daily optimizing and developing on birds, on the flapping birds, like the peregrine falcon, also with fixed wing birds. And our latest project basically are going out to more unobtrusive surveillance birds for police, special forces. Think of large birds with 2 meters span width, and we can equip with a camera.
All right, I think we got this.
Okay. This is the drone bird, remote aircraft that looks like a bird of prey, looks like a peregrine falcon. Its purpose is to scare real birds, and 3D printing allowed this drone to go into production.
The Drone Bird company developed this product initially with a fuselage made through hand layup. They worked with Parts on Demand to transition the body and some other parts on the drone to SLS 3D printing. ALM provided the glass-filled material that provides the lightweighting and the durability that's needed, and they're now working on new variations of this drone as well, including fixed-wing models.
When we were researching this episode, we learned something more. Parts on Demand is located in the Netherlands. Major food exporter Neil, who you heard from in this episode, had a lot to say about 3D printed automation for the food industry. It's really interesting, you should watch. Our All Access subscribers got to see that, and you can see it too. Signing up is really easy. You'll get advance notice whenever a new episode appears and extra segments just for subscribers. It's free, thecoolpartsshow.com/allaccess.
And if you have a cool part, something that takes advantage of biomimicry, something that uses a new or unique material, we'd love to hear about it. Please email us, coolparts@additivemanufacturing.media.
Thank you for watching. This episode's brought to you by Carpenter Additive. We're past the point of not knowing how to qualify metal 3D printed parts. We know, it's just that different end users of those parts have different qualification requirements. Additive manufacturing service providers have to navigate that, and Carpenter Additive has to think about that in tailoring powder management solutions.
Our customers typically will have, if they are a service provider, they will have a series of end user customers who may be, say, OEMs in the aerospace world. And each of them has a fairly large team of engineers who've been doing this for decades or more and have developed all these standards, regulations, paperwork. So it is certainly a challenge to thread the needle between all of these different requirements. We start really high level, we walk on the shop floor, we ask them about, okay, source to sink, how do you bring in the materials, goods in, send that material to each of the systems, and then what we're really interested in is how do they reuse that material. So what we do is called a value stream map. Pretty often that leads to a series of things that were either overlooked or hadn't really boiled up to the surface yet in terms of things that are potential risks or potential challenges or inefficiencies that exist. A lot of the customers we work with, especially in the more regulated industries such as space or medical or aerospace, have already been through those early learning stages. They've put 5+ years into this. They've done the product design and the design for additive manufacturing. And now they're starting to reach some of the more finicky problems that you get when you're at the scale of maybe 5-10 machines. You're running different materials simultaneously, you're doing different programs. We get to take the best from the medical field and the aerospace field. We understand the specifications and the standards that exist in each of those fields, and we can sort of take the best elements of those and customize that to our customers.